Cool. So yeah, as we talk about on Monday, homework three would be, one is about this sound, earth, and moon thing. So you don't technically need to do it with class. So basically it's just playing around with the rotation and, calculating cosine and sine, angle, stuff like that. But for Q2, we will be using class. So, you'll basically implement um, the star object, star class. So you will be provided with the template sketch. So the sketch is already pretty much done. So what you will need is that there will be, star.update, star.show, and that's the two things you need to, implement. And the constructor is here where you have the size, the speed, and the color. And pretty much this is what you want to finish. So you want to do the constructor, what would be the input signature, like what would be the input parameters to, construct the star. So you want, no, that's not the size, that's the radius. So how far away it is from the sun and how fast it is in terms of, the theta, the increment in the angle and the color. So you will want it to be here so that the constructor will take those three parameters and store into radius, speed, and the color. And you will also do these two things. So show will likely just be a circle thing. You just want to show the star with the correct color, correct size. We are not doing size here, so just pick whatever size you like. And the most tricky one will be updating the position. So the star will have its own, theta that you will be keeping track of. And that's the benefit of class, because you will have, several stars rotating around, and each of them has their own, states. So they will have their own position, they will have their own color, they will have their own speed. And, class allows you to have this container that store those things. Cool. So that's pretty much what you want to do in homework three. So working with class. Cool. And so you should be able to get this. And the fancy fading effect is just I've already provided it out in the template. It's basically, whenever you do the same thing again and again, instead of using background, parameters, some number, and then we'll just clear everything off. Now we are applying, say the previous frame, you have all the star like this, and now you just basically draw an equal size rectangle, and you set the alpha value equal something that's not completely transparent, but not completely, not transparent. So, set something like alpha equal 25. And so every time you apply that transparency, semi-transparent filter on top of the thing. So, the last one will be a little bit fainter, and, everything else will be getting more, fainter and fainter over time. So that's the, the trace effect that people tend to like it. So we are also doing that in here, where you see this fading effect, where you basically just fill a certain color. This color is the background color, but now you set the alpha value to 50 rather than 0 or to 55. So if you do background, basically you're setting a non-transparent color and you cover everything. But now you're just cover a background, but with some transparency. So things will get fainter over time. And basically that's being done by just applying a rectangle on top of your canvas. Cool. So that's homework three. Questions? Cool. Have fun with class. Yeah, usually class is the biggest issue whenever people working on Java processing, C++. But But it shouldn't be too tricky in this case. Pretty much you have the sketch, you just need to implement that class. Cool. And homework 2, all good. There might be a small issue sometimes if the GIF, sometimes you will only get like one single frame for when it's game over. So to fix that, you want to save the frames even if it's game over. Otherwise, you only get one frame for game over. So that's just one tiny nuance. It's fine if you couldn't, don't have time to make it perfect. But that's one thing, you have to sort of like, even if it's game over, you still want to keep the program running. You don't want to freeze everything, just that you are not updating anything on the canvas. But you are still saving those frames so that, the longer you wait, the longer you will see it in the GIF rather than, well, completely shut off. Cool. Hopefully everything good. So just a recap on what we've talked about for object and class. So class is, defining what an object is like. And once you initialize something of a certain class, then it becomes an object. So this thing is called the class. And once you initialize that, like this ball, now it's an object of that particular class. So it's a little bit, confusing on the terminology. But class, think about it more like a template. And object is the actual real stuff that you just created. So we talk about class. So just to remind you again, likely you will go through it in homework 3. But these are the fields. That's the variables to stored with that class. So think about this ball. You want to know where it is currently. Think about now you have like 100 balls. Then you want to know for each ball where they are. So you want to have like X, Y, for example, size, for example, speed X, speed Y. And in homework 3, you want to know where the angle is, what the color for that particular star is. So all sort of things that you can store. And think about it more like the state of an object. So you want to store where it is so that once you call that object, you know where it is, what its color is like, what's going on with that thing, basically. And you have constructor. So this is like an empty constructor. So you can also provide different things so that you can, initialize an object of a certain class. And you have a bunch of methods. So methods is just the functions of a class. Think about that way. So we talk about this, the basic bouncing ball class. So you can, declare just like you have a variable. So you have the data type. Now it's a class ball, and you initialize that particular object. And you initialize it by using this new thing. And you can call the methods whatever you like. So the benefit of a class is that, well, this is like you now get one ball, but what if you want more? So you can actually just do it the same way. Now you get 2 balls at the same time. And we talk about this polymorphism, which is, in the constructor or even like any function, you can do it this way. So think about, some of the function we go through, they have like, say, random. You can provide one single number, then there will be the upper bound. If you provide 2s, now the first one become lower bound rather than upper bound. So there are like different ways you can call the function. So that's the same for constructor, and that's called polymorphism. And so you can basically provide different signatures to the constructor. And then you can do something like that where you, specifically provide the initial starting point rather than having everything randomized. So these are like 2 different signature that you can use for the constructor. And I also mentioned that the processing Scratch is an is this Sketch or Scratch? It's Sketch, right? Yeah. Oh, okay. That's a typo. So processing Sketch is an object in Java. You cannot access it, but you can think about it that, well, there's hidden structure inside Java, and everything somehow is also a applet object in Java. Cool. And we talk about this p vector thing. It's also a class where you can, better deal with these like two number thing. So likely in homework 2, you already experienced that. Well, you always need to work with X and Y, and somehow they are, binded together somehow. Sometimes not, but in some case, it will be a lot easier if you want to work with them as a bundle kind of. And you didn't really see the benefit of doing that. It's basically just make it more complex. But think about some of the other things you can do with p vector is that you can do random.2D, get a random 2D unit vector. So that's something we will appreciate, especially when we want to get a random direction. So this is very convenient. You can also set the direction range. So that's basically what you want to do in homework 2, where you want to set the range so that it get that, when you initialize the game, you want it to be upward. So there are some benefit of using p vector, especially you're calling these like class methods. Cool. Cool. So today we will talk about list and data IO. Basically, we will talk about the sum library. This is a class in Pad, but we haven't looked into anything about sound yet. So today we will get to look into something about, visualizer. And that will likely also connect to, our midterm assignment, where we want to build a music visualizer. It will be open-ended, so do it whichever way you like. But homework 4 will be the first version of, like a basic music visualizer that we can do. Any questions so far? Cool. Anything we've talked about? Oh, and I also created that Google chat. So if you have any questions on assignment, just post there. Feel free to exchange. Just don't share your code as it is. Anything else, code snippet. I think that's fine. Yeah. Cool. So today we will talk about list. The list is a little bit different from array, as we will see, and that's all the complexity comes in. But that's also one of the most important data structure. So we would just go over that and, imagine there are tons of other data structures that we won't go into details, but, that's being used in across different programming language. And there's, always that data structure class that semester long talk about everything about data structure. But list would be one of the simplest data structure. Cool. So what is a list? So list is similar to arrays. List holds several items of the same data type. Actually, it could be different data type. But lists are built to have a dynamic size. So it's different from array. So array is that we talk about like when you start an array, it has to be determined. The size has to be determined. So when you initialize an array, you want to say something like float. And then you have this square bracket, and then, you want something like, I don't know, X equal, new load, oops. And then you get the square bracket, and now you want to put in the actual number of stuff that you need to store in this particular array. So the array has to be predetermined the size. But list doesn't have to be like that. You can actually get a bunch more. So one of the most simple things about list is that you can just do this into list. It's a pre-built thing in processing. It's not available in Java. And to work with is pretty straightforward. So you just do int list, say position equal to new int list. So this is pretty much, look at it, it's just like a class. So you can think about, and a list is just a predefined class where you are initializing a new position that's this class, and you are initializing the new object. And so this object is pretty nice because you can do all sort of things. It should be self-explained in some sense. So you can do position dot append. So now you get, you start. So usually we draw it like this. So you start a list. So this is position. It will, point to somewhere. So now you append 100. So now you have the first thing as 100. And now you append 200. And then you append 300. So this is your list. You have 100, 200, and 300. So now what you want to do is that, instead of the array where you do, array.length, now you do post size. So it will calculate how long this is. So if you do, pause the size, it will return 3. It will count how many stuff you have. And then to get a specific item, you can do, what's going on with that? Position.get, so that you get the specific things. So this will be get 1, this will be get 2. Oh, actually 0. Get 1, get 2. So everything is 0 based. Cool. So this is the way you can just initialize the list. Should be self-explained in some sense. So pretty much similar to array, but rather than the array where you have to determine everything. The list, the size of the array, you have to determine it, predetermine it. For list, you can append, and append. So it could be, much longer or shorter, depends on how many stuff you want. So you can also do the same thing as the array, where you can do for each loop, so that you don't need to go over this thing. This for loop, you can also do for each loop, as we talk about for array. So it's the same thing. So pretty much, array and list look similar. Where the array, you want to have this square bracket, and you have this new, and you have to determine the size of it, and then to set the number of a specific array position, you want to just use the square bracket syntax. But for the list, you want to append, so that you get 100, 200, and 300. When you want to get a length, it will be length versus size. I mean, just look at it. There are different things. The length of the array will be that length, and the length of the list will be parentheses. And they are different. Well, so I have a question for you. Why is that this is like that length? There's no parenthesis, but this has the parenthesis. Property. Yeah. The size of them. Yeah. That's exactly what's going on. So as I said, array, this 3 is predetermined. So, once you set this up, you already know what that size is, and that size won't change. But for the list, you don't know exactly how long that is. When you initialize it, well, it's just a list, who knows how long it is. And then you append stuff, the list, the size will just change. So the length of the list is actually being computed whenever you call that size thing. So it will just go over that. Well, now I start from here, and then I look at, well, do we have another one? Yeah, we have 100. Do we have another one? We have 200. Do we have another one? 300. Do we have another one? Well, no more. So it will return these 3 things. So the size is sort of like being, compute on the fly. And that's why you have the length of the list with the parenthesis. But for array, it's a property. It's sort of like a field of that class, or, technically it's not a class, but the way how you can compute the length is much easier for array. Cool, and there's a tons of, list methods. You can do size. That's what we talk about. Get. That's what we get. A specific index versus, for array, you can use square bracket. You have append, we talk about it. Insert, if you want to insert a number specifically, say 100, 200, and you want a 250 somewhere here, you would do insert, so that you get a specific index, and then you put it in. You also have set, so that will be equivalent to this. So say once you have like 100, 200, 300, you want to, change the things into 400. Then what you would do is like pause the set, and you want the second one to become 400. So this is the syntax that we use. Set the first one into 400. Then it will be equivalent to this thing. And remove, clear as value. You can do search for a value. You can clear everything so that it becomes 0. Not 0. You just clear the whole list. And remove will be removing a specific index. And also you have all these different things. You can sort, you can shuffle it, you can add all the numbers by something, you can subtract, you can multiply, you can divide. So pretty much just like arrays. But one thing different about array is that everything is now in place. So as we talked about previously, where we talk about array, whenever you do all sort of like things like sort, I say that you will always get a new copy of the original array rather than the original array. So you won't get a you will always get a new stuff coming back. But it's different from the array. Now list will be in place. Yeah.
So arrays and processing can't do anything in place. That's just a limitation that they have.
You can do stuff in place, just that most of the predetermined, method, it will honor in place.
Oh.
Yeah. So if you do sort, so you do a array.sort, it will give you something else. It will give you a new array. Okay. So it cannot do stuff in place.
Oh.
Technically you can, but anyway, that's the default behavior.
Stuff. So you can modify it.
Yeah. You can always modify it. Yeah.
But
yeah.
the default
yeah.
for the list are
exactly. Yeah. And so that's a detail. But basically, in place versus not in place algorithm is one thing kind of important, because oftentimes you will get undetectable bugs when you confuse them together. So in place algorithm, meaning that you are not creating extra space, you are just swapping different stuff at the same time. And not in place algorithm, you need an extra memory. So we have some examples here. So think about, this like non-in-place algorithm. This is like the radix sort. So think about how we are going to sort this array. So one of the simplest way is that, well, let's just look at, that's probably how human do it. Let's look at the lowest digit, and we try to sort the lowest digit. So, you can basically just have like 10 bucket, like 0 to 9, and you look at all the, lower, the rightmost digit, and you basically just put them into different bucket, whatever order that you see. So now you see that, 24, 84, 65, 15. So you haven't sold these two things yet, but now basically you just go through one by one. So 65, you put it into the bucket of 5 because the last digit is 5. 24, you put it to 24. 84, now it's the same bucket, but it will be the last one because you haven't compared them yet. So you're not doing anything comparison. You're basically just looking at the digit and put them into different bucket. So once you've got all these things, now you just go through it, and now you get all of these things. So if you look at the the rightmost digit, everything is sorted now. But the left hand side, the leftmost digit is not sorted yet. So now you do it again. Say you have like 0 to 10, 0 to 9 buckets for them. And now you basically just go through it, the same thing. So 3, 1, so you put it to the 3 bucket. And then you put 6, 1 to the 6 bucket, 7, 2, 1, 2, 24, 84, 6, 5, 15. And so now you see that, well, everything now gets sorted perfectly. And if you just flatten that, then you get the perfectly sorted stuff. So this is what we call a non-in-place algorithm. It is called radix sort. So what's happening is that you actually need this extra, stuff to store the temporary stuff that you need to do the sorting. So this is an example of a non-in-place algorithm. So, after that, everything will be sorted, but you need extra memory to store intermediate radius results. Question on this? Sounds like an algorithm class. But anyway, just give you an example. And there's an in-place algorithms, and likely if you've taken any algorithm class, then there will be a bunch of in-place algorithm. And there's a reason why people like in-place algorithm, because you don't need extra memory to do anything. So how do we do insertion sort? So basically, you start from the second one, you grab 24, and then you look for everything else. And then you want to see where, actually, you start from 65, and you want to know where 65 should go. So for this, you compare 65 and 24, and now 65 is larger than 24. So then you swap them, and then you put 65 to the second one. And now you look at the next one. So now 24 and 65 is sorted. So now you look at 84. Now you compare with the previous thing, 24 or 65. You compare with 24, it should be later. Compared to 65, it should be later. So now 84 should be here. And now you grab the next one, 15. And now you compare with 24, 65, and 84. And you realize that 15 should be, in the first place. And so you keep doing this thing. So now you have 72. So you compare 72 with 15, it should be later. Compare with 24, it should be later. Compare with 65, it should be later. Compare with 84, it should be before 84. So now you want to put it in that specific position. So you just keep doing this again and again, so that the last time now you have 61 and everything else sorted, but now 61 should be somewhere between 31 and 65. And so this is called insertion sort. And the benefit of this is that, well, you don't actually need any extra memory to store the intermediate results, because all the time you are basically just moving stuff around. You are just swapping, the array, all the numbers in the array so that you move to the correct position. So you don't need extra memory to store your intermediate results. So that's what we call an in-place algorithm. So that's sort of like show you what's the difference between an array and a list. So when you're doing, array, when you do sort array, what you will get is a new stuff. So you will always get a new array. But for list, when you do the sort, you will do it in place. So you won't create a totally new array. So pretty much you can do similar. So for list, the sort is a method of this particular class. So you need to do list.sort. But for array, you just need to call sort parenthesis array. So it's slightly different. But anyway, the big difference is that you will get a new sorted array. But for list, you will get the original list, but it will be sorted. So sometimes it's a little bit hard to, debug if you don't have, the correct mindset of working with list and array. But anyway, I guess the big rule of thumb is that most functions working with array would be, not in place, but most stuff with list will be in place. Cool. And you can actually turn, convert between list and array, list.to array. You will convert a list into an array. there's no easy way, other way, easy way around. The other way around. So if you want to create from array to list, you just initialize a list, and then you just append through the whole array. That should be the easy thing. And there's also tons of difference between an array and a list. But I would just go through it. Likely these are more like an algorithm data structure class stuff. But array, the size will be fixed, list will be dynamic. That's the biggest difference. And the data type, array would always be the same. List doesn't really care, but most of the time, if you're using int list or float list, then everything should still be the same data type. But it can be different. The speed, array is much faster due to the implementation, because array is a contingent chunk of memory. So you only need to know where it is. But for list, you have to sort of like route it toward the correct number. So it's much slower. And for memory, array is much lean in the size. List, it's higher in size. And you can actually do multi-dimensional array. That's possible. It's a little bit tricky. And that's why in processing, even the image, a 2D image will still be stored as a 1D array. And, so that's kind of show you that, well, multi-dimensional array is possible. You can store 2D array, but still, most of the thing in processing is still in 1D. And for list, there's no way you can do it. Cool. So one of the things that we will be doing later is list of objects. So that's very confusing. So array list is a list of objects. So it's a very unfortunate name, but anyway, that's array list. So think about this are the two things. So ball, square bracket, balls, new ball 20. So this will initialize an array of 20 objects. So this is sort of like in homework 3, what you will be doing. Say you have like 9 stars, 8 stars, whatever number of stars, you know how many stars you have. But if you don't know how many stars you need, you want to click and add the star every time, or think about the bouncing ball. If you want to click it and you get a new balls, then you want to do this array list. And the syntax is a bit complicated. So array list, and then you have this angle bracket where you determine the data type of that. Anyway, this is the syntax, array list. This will be the data type, meaning that this list have that specific data type. And you want to do the same thing as how you initialize a class. So example here is that string is, as we said, string is sort of like an array of character. So it's more like an object. So if you want to do a string array, it would be strings and new string 20. But if you want to do a string list, then it will be a list of string. Cool. So one thing we could do, likely a little bit tricky now. I think we can just go over this. So what we want to do is that I will give you the example ball.pde. So if you go to our website, where's our website? The thing, and then you have this ball.pde. Yep, that's it. So go ahead and download that and try to implement this. Let me send it to the chat. It's also a good time to try that. Cool. I just sent in the chat on Google Chat where you can find the ball class. And now what you want to do is that you want to add a ball whenever the mouse is clicked. Think about how you're going to do it. So this would be different from, in homework 3, where you are basically predetermine everything. But now you only want to create a new object, and that's interactive, that's dynamic. So that will showcase why we want to use list rather than array. So to get you started, you will open up processing, and let's go to click the link. So you will click the link and download everything here and put it into a separate tab. This is basically what you will also be doing for homework 3. Cool. And so now you have this class of ball. And now how do you implement the main file? So we will explore 2 things. First, we could try an array of objects. So say we have like 20 ball, and we would just show it one by one. But we will also look at the array thing. Cool. So let's get started. Think about how you're gonna do it. So we could just do the most simple thing. Set up, draw. So we will want to do this. So ball, square bracket, balls equal to new ball 20. So this will initialize an array of 20 balls. And what we are going to do is to, to add a ball whenever the mouse clicked. So we will likely have this function. Mouse click. You want to do something. And you want to also show all the balls. Cool. Please try it. I've shared the ball.pde thing in the chat. You will want, to randomly get the ball at the random position. So think about how you can do it. We kind of skipped all the exercise on Monday. So now it's the time to get familiar with the class. Somehow it will stop whenever I click somewhere else. Anyway, you get the idea. Whenever you click the mouse, you will get a new ball at the random position with a random speed. Okay. Any progress? Kind of. So think about what you need. So the downside of having an array is that, for other ball, you pretty much don't know where they are. So you want to have a count that how many balls you have, rather than, relying on this 20. Because some of them are not initialized yet. So you want an integer count so that you know how many ball you have. And whenever you click the mouse, you want to add that count for 1. So this will be something I'm implementing, but I guess think about it for a while, and we will look into how we can do it. So I guess this is what I have. So nothing when it started. And I click and you get a ball, and I click and I get another ball. And the maximum I can do is 20. I think after 20, yeah, it will crash because I forgot to do it that way. So now it's larger than 20, then you will get some issue. So that's the downside of having this array. I should the function for that.
Import your one scripting in code. Like if I wrote a ball class and a collision class that I just wanted to use for all the assignments.
Yeah, the easiest way is just copy that into this things. So typically you just put it next to your file.
Okay.
You can also import, but it will be a little bit trickier.
Oh,
Yeah.
importing is not as
I think there's technically some way to do it, but typically when people are doing processing, it's not that big, the project is. But you know, we would talk about like, oh, the library is basically doing that. You can actually write the library and then you import the library and you have everything there. But if you're just writing classes, then you can just copy paste. Yeah, you can always write a library, but it will be a much larger package. Yeah. So, you know, this is the new tab, but when you click save as, you know, if you want to save the thing, it will actually save the main file as whatever you named it with, and this will be saved alongside that file as a standalone PDE file.
Oh,
Yeah.
so these are all part of the same project. You can access ball.
Yeah. As long as they are in the same folder, then they will be in the same project.
Oh,
Yeah. So a folder, there will be multiple file. There will be one main file. That's this thing. And you will have a bunch of class. That's usually how people do it. And most of the time, it's not a big project. And if you're doing bigger project, then you can have like libraries. Yeah. Cool. Any progress? Have you get one ball initialized? You mean this?
yeah, yeah.
Oh, you can download it from the chat. Yeah.
Oh, it's.
Yeah, in the chat. So here, this thing. Yeah, so you will just go there and copy paste everything by, you know, create new tab and you want to name it with ball and then you copy paste everything. And now you can have access to this ball class. So now if you do this thing, you will have it. Cool, I guess I can start with a new file and let's go over it. Hopefully you've got something. So we sort of like didn't do any exercise on Monday. So that's started with this. So what we can do is that, you know, we can start with just one single ball. So we'll have a ball, ball, new ball. Is that how I do it? No, I don't want to initialize it. And so what we can do here is that, well, now we initialize this ball as a new, oh, I forgot to add that thing. So now we want to have a file that's the ball class, and we open this thing up, and we copy paste everything, put it here. So now we have the ball class that we can have access to. So now we initialize the ball, and now what we want to do is to we declare a ball, Now we want to initialize it. So where should we start it from? Say 200, 200, size 10, speed X, 3 and 3, whatever. And let's forget about the for loop yet. So this is basically what we have, to create a single ball. Hopefully this will show up. Yeah. So once you do this, you can get a ball. So it will start with, 200, 200, that's X, Y. If you look at the constructor, X, Y, size, speed X, speed Y. So, now speed is 3, 3. That's why it just keep jumping for the diagonal. But now if you do something, different speed X and speed Y, now you got, a smaller angle for smaller speed X and larger speed Y.
Then it's a food from faster turning ball in my not check but
Did you get this?
Yeah. It's in my second tab.
Hold on. Let me see. Yeah. Oh, likely. Yeah, likely you don't want to name it this. I don't think that's the reason. You just write something, maybe it was just yeah, okay. Likely lowercase. Okay, yeah. I don't think that's the reason, but when you write alongside, sometimes processing will show some, errors. But as as you progress to write something else, the error will just go away. Cool. So this is the way you create one single ball. So now the idea is that now we want to get more. So ball 20. So now we want to turn this into an array. So, the way how we do array is that we get a square bracket. And now we have multiple balls. So now we rename that variable into balls. And you want to use new ball 20. So this, so that your let the machine, that processing knows that now you are initializing 20 ball where you will initialize later. So now what you want to do is that now we don't want to have the ball initialized at the setup. Now we want it to be initialized whenever you click the mouse. So now we want to add another integer that's count, where you want to keep track of how many balls you have. And now we add add another function, mouse clicked. And so basically this is where we want to think about how we initialize these things. So we want to turn this into the mouse click part. So now whenever the mouse is clicked, we want to set the ith, the count. So we have the count initially as 0, right? Where's my mouse? So we have the count initialized as 0. So now when the first time we click this mouse, we will initialize balls count with a new ball. So 200, 200, 10, 2, 3, whatever that is. And now we want to increment this clown. So you can do count plus equal 1 or simply just count plus. So now, you initialize the first balls 0, and now your increment count become 1. And so that will give you the first ball. And now this is a little bit trickier in the draw, because you basically want to go through all the ball that you have. So you want to go from integer I equals 0 all the way until I is smaller than count. You want to go over 0, 1, 2, 3, 4 until count -1, and you want to do I plus. So, this for loop will just go over all the balls in your class. And now you want to do balls I. So what this for loop do is that you go through I equals 0 all the way to count. So this thing just go through all the balls that you have. And then for each of them balls, I will get you that ball. You move it, you check whether it hit the wall, and then you show it. So you pretty much do it for all the balls. So now if you do it this way, well, whenever you click it, you will get a new ball. And then when you click it, you will get a new ball. And every time it will be from the center, because that's where you have this 200, 200, 10, 2, 3. So all these balls are being, initialized at the same place. Question so far? Have you been following up with that? Hopefully. So you can do a lot of things. So, you can do, we want a random X. Let's think about float X equal random, 0 to width. You don't need to do 0. And float Y equal to random height. So you will get a random X and random Y. So let's see what we get. So now, well, now we can get a random position of ball at different places. But now they are moving in the same direction. So now you can also do speed X, random. You don't want it to be too small. So 1 to 3, float, speed Y equal random 1 to 3. So now you will get a random speed. Actually, we want it to be -3 to 3. So now it will be a random direction. Forgot the semicolon. So now the speed will also be random. So this is unfortunate, like both are too small. But anyway, all of those would have a different, random X, random Y. Size is the same, random speed X, random speed Y. So you will get a bunch of different things. You can also do something other than random XY. You could also do mouse X, so that, wherever you click, you will get a new ball at where you click it. So, now if you do the XY as mouse X, mouse Y, so I click it here, it will start a ball there. If I want the ball here, you can just click on different places to get a ball. So now it's time to see, we have like 20 array. So if you're writing this way, and if you click until you get 20, then the whole thing's just crashed. And if you look at this array index out of bound exception, so index 20 out of bounds for length 20. So think about this count. You will go through 20 and now it becomes 21. But now if you do balls 21, but your array is only 20. So now you get that out of bound error because you don't have that many buckets in your array. So to fix that, you can basically just stop everything when you have that count. So you could do if count larger than 20, you would just basically do nothing. So this is one version where, well, everything will just stop when I have 20 balls. So once I have 20 balls, everything will just stop. There's another way. You could also just restart everything. So you could also say, well, let's just return to 0. So this index will start replacing the first ball that you initialized. So you could also do it this way. So now think about when we have 20 balls. This is a little bit tricky to see. Let's just do 5 balls to see what's going on. Say we have only 5 balls. So 1, 2, 3, 4, 5. So this is the first one. So now I click next one. Okay, this is 5. Let me close that. Cool. Cool. So 1, 2, 3, 4, 5. So now once we are count equal 5, we will reset the count to 0. So we will get through, get rid of the whole thing, and we will restart again. Questions? Oh, good. Now, next challenge, how can we use the list so that we can, do beyond just like, 20 volts? So this is the syntax for doing array list. So think about how you would do it. Now, you don't need to keep track of the count, but you will add a new ball to this list whenever you click the mouse. So this is the syntax, how you start that list. Array list ball. So you likely need a bunch of functions to work with the array, to work with array list. So now you have balls. You want to get I so that you get that thing. You also want to have balls that append so that you can initialize stuff. You also want balls that size so that you get the length of it. Oh, so you want to use add, not append. Cool. Any progress? Your code should be cleaner with array list. Cool. Let's take a look. So pretty much it's just similar to what you just did with the ball array, but now you want to use this. So array list. So you start a list of objects, and the object type will be ball. So you will have a bunch of, a list of a bunch of ball object. So now if you look at the mouse click, now you want to, initialize a random speed x, speed y. You want to initialize a new ball. But now what you want to do is that, well, we will get a new ball object. And once you have this, you add it to the list that you have. So it will keep adding new ball object to that list of objects. So this is the way. So add, sometimes it's append, sometimes it's add. So for array list, it's add. But if like an int list, things like float list, then it will be append. So sometimes a little bit confusing, but for this case, you are adding a ball to that. So now this, whenever you click it, you will initialize a new ball, add it to the list that you have. And so for the draw function, now you just change all the stuff from array to a list. So now you go from integer I equals 0 all the way to balls dot size. So that's how you get the length of the list. And that thing will keep growing when you add more stuff to that. And to get the specific one, so before, if you're doing an array, it will be balls square bracket I, but now you will do dot get I. But pretty much you will get the same thing. Get I, you get the ice ball, you move it, you check whether you hit the walls, you show it. That's it. So you will get pretty much the same thing. And now still you can do the same thing. And if you want to get it even more, cleaner, what you can do is that, as I said, you can do a for each loop. So now you will say ball, ball, balls. Is that how I do it? Did I write something? Oh, yeah. So if you do this syntax, so this syntax is just as it is. We have a bunch of ball that's inside this thing for each ball involved. That's it. And you want to declare what its type it is. And so if you do this, pretty much do the same thing, but your code will be much cleaner. So this should be, I guess, the cleanest way. It's much shorter and very easy to follow. Questions? Why do we need to be this complex? Yeah. So, imagine like you're implementing a different, think about a game where, you'll have like interaction where user can, basically create their stuff. Or think about you are drawing something, you want to keep track of that thing that the user draw. So, a bunch of things that you can work with in class is that, well, each of these ball will have their own speed, will have their own position, and everything will be stored in that object. So that's the benefit of an object. And now if you have this array list, then you can create a slowly growing size of list that store all the objects that you created. Cool. So I guess that's the complexity, but also the beauty of what it is. Cool. Just go over everything. I don't know what's going on. I think I copied the same thing again. Okay. So this is just repeating what I have. Anyway, just again, the difference between array and list. So when you do the declaration, for array, there will be square bracket. For list, there's no square bracket, but rather a new, you're sort of like creating a new object. And when you want to do initialization, it will be in the square bracket. But for list, you would do append or add. And the length of an array will be dot length without parentheses. The length of the list will be dot size parentheses. Cool. So we just go over this, sort of equivalent but different. For the array, there's no way you can get more ball beyond 20. There's also the way that you can just dynamically increase the size of array. So, if you're running out of space, then you create a larger array and you copy everything in the previous array to the new array and you keep expanding it. That's one way, but for this, you will just dynamically grow that list. Cool. So what's going on with the title? So we would talk about libraries and so we would talk about working with sound in processing. And before that, we should talk about library. So as I said, we have these we have these all the classes, but actually there's much more in processing. So we talk about all the building things. Oh, I thought it was my where I am. Cool. So if you click tools and then you click this manage tools, it should show up this thing. So that's where you install the movie maker, right? But now at the top, you will see this library things. So now you can actually install many interesting stuff. So at the left is the name of the project. And if you look at the right, the author, and sometimes when you scroll, you will see this is like the official sign. So if there is this processing logo and say processing foundation, that's the official libraries that's being supported. So what we will do now is go through and find the sound library, and now we can click install. And that's what you need in homework 4. Cool. So now once you install this sound library, then you can do a bunch of interesting things to work with your microphone, do FFT, do amplitude, do pitch detection, do what else? Beat detection. So those might become, useful for your midterm assignment. So there's a bunch of like processing, official libraries. So sound is the thing that we will look at. Video, that's another thing. It's a little tricky, but anyway. Hardware I/O, this would be, connecting with Arduino or, other embedded system. Java FX, I don't quite know what that is. I think it's for animation. And there are also so many other third-party libraries, networking, GUI, animation, vision. This is something we will look into next week. It's pretty fun. Using deep learning, AI visual processing in processing. Cool. So sound library is the thing that we will explore for the 5 minutes left. Likely we won't have time. So a library is basically a collection of classes and functions. So, there's a bunch. So you will have sound file, audio sample, audio in, multi-channel. So that's some of the built-in class, so that, audio in is so that you can access the microphone input. Sound file is for you to open an existing file. So, in midterm assignment, you could, use audio in so that, you sync if you like. Or you could just use sound file to load a file so that you can build your music visualizers account. And you can do a bunch of analysis. You can compute the amplitude. You can use beat detector, pitch detector to get those. You can also apply FFT. That's what we will explore in homework 4. Effects, there's a bunch of effects, just like, typical synthesizers. You can do delay, reverb, low pass, band pass, high pass, low pass. So if you like, you could also do some very simple modification of the sound. And you can also bring noises, white noise, pink noise, brown noise. This is likely not the best sound library in the world, and processing is not technically built for sound, but we can still do a lot of things from just, think about, you get a sound and how you render something in processing. And later, the second half of this class is about max processing, the max MSV. And in that sense, there will be all about sounds, and processing is more on the visual side. Oscillators, and there's something else. And you can actually find all the documentation online where you have all the libraries. You can actually look into what are those things that you can get. There's a tons. I just sample some of those. Analysis, I/O, sampling, noise, envelopes, oscillators, configuration, things like that. Anyway, I guess we don't have time, but this is amplitude class. I will show you next time. So basically this, I guess it's just I'm talking. So it will in the start. So this audio in will be the microphone. And then you just analyze the amplitude and you show the amplitude by the circle. So the circle size would just be the sound, like the amplitude of my sound, my voice. We will show you next time. Cool. You can also do pitch detector. So now the line will be where my pitch is. This is like the basic format of it. You can do something fancier. And in homework 4, we will be looking into FFT. So FFT is like spectrogram, spectral analysis. So this will be x-axis will be the frequency, y-axis will be the amplitude. So you are thinking about, we are analyzing what's the frequency components of of what I'm talking about. Again, this is audio in, so this is I'm talking, this is I'm singing. So you see the difference in the spectrum, where when you are talking, the spectrogram won't have those stripes. But if you are singing, there will be stripes because you have harmonics in when you are singing. Yeah.
Is that being like the fast Fourier transform?
Fast Fourier transform.
Is the same with these sets? Well,
Same for through it. Yeah, that's basically fast Fourier transform. Yeah. Yeah. So this thing will just do fast Fourier transform for you, so you don't need to write anything. But yeah, that's fast Fourier transform. Yeah. Cool. So that's basically homework 4. If you like, you can explore it. I guess it's self-explaining. We will get into this after I'm back, but that's what homework 4 will be about. You see that this is what I will give you in the template sketch. Everything is very sort of like limited. Pretty much these high frequency part, nothing there. So you want to rescale the array. So you have to work with the array and try to visualize it correctly. And you will also implement this, fancy trace thing that will just, record the maximum value that you get, and it will slowly goes down, falls down. And then once you have another thing, you will push it up again. And that's what you want to do. So think about how you're going to do it. So likely you need another array to keep track of the highest point. And whenever, as the time going, it will go down, going down. And then once you have another thing, push it up, then you will update it again. So that's basically what you want to do in homework 4. Other than the example sketch, everything else is just processing the array, working with arrays and, doing random stuff, trying to make it look cleaner. That's it. Yeah, so we won't have class next week. So see you next Monday. And homework 4 is also up, so you can already explore it if you like. Cool. And if you're wondering what FFT is, on homework 4, there's a nice video at the bottom explaining what FFT is if you're interested in. Cool. But that's not a must. You don't really need to understand FFT to work with homework 4. Cool. See ya.